Hello. I'd like to take some time and talk a little bit about the Wepman, Jones, Bach, and Van Pelt article that I've asked you to read. You might wonder why I'm having you read an article that's so old, and it really doesn't have any data in it. It's really kind of a piece that talks about what language is and what aphasia is. And I'm having you read it from a historical perspective. So one of the things that I think that speech language pathology sometimes does is to forget its past. If you were a psychology major, you would automatically learn about Freud and Jung and the leaders of the psychology field and how we've moved from what they thought or believed or postulated to where we are today. You would learn about behavior in terms of Skinner and Chomsky, etc. In the field of speech pathology, we often pick up in the middle, I think. So I want to give you a historical perspective on how is it that we've come to understand aphasia. And this is one of the seminal articles. This article is actually going to dovetail into and feed into the definition of aphasia by Darley. And Darley used this work by Wepman to form his definition of aphasia, which is the definition that we're going to use. And we're going to read about why it's still a good definition even in the 2000s. So to get started, I want to point out this diagram from your article. You can see that it's not very clear. It doesn't photocopy very well. And so what I've done is taken this diagram and I've reconstructed it in PowerPoint. So I want to explain this diagram to you. The idea is that we have end organs that are receiving sensory information. Those end organs include our eyes, our ears, and our body. Information then is modality bound. That is, the information from your ear goes through auditory channels. The information from your eyes go through visual channels. And the information from your body is going through tactile channels. And they're being transmitted. This transmission of information throughout the central nervous system, takes on many, many forms. And we, of course, understand this transmission as being very complex and involving many areas of the brain. Information then is integrated in what Wepman called a symbolic formulator. And this part of the model is modality linked. That is, the things that you see, you hear, you feel are all together and are being combined to help you form symbolic understanding and symbolic expression. After you have understood a thing or are getting ready to say a thing, you're going to send that information out, perhaps. Oops, skipped ahead here. You're going to send that information out, perhaps. You're going to transmit it out. It's again going to be modality bound. It's going to go out to your mouth, to your hands, to your body, right? In the terms of your mouth, speech is going to be the output. And the speech is going to be verbal. That means word-based, right? We're not going to use the word verbal in this class to represent speech. When we mean speech, we'll say speech. And when we mean verbal, we'll be talking about something that's based on the auditory word. The information is sent out. It's modality bound, so it goes out the motor speech system. It goes out the hand, and you write. Could go out through a gesture through your body and be some kind of communication to another person. So it ends up again at the end organs. So this is the basic system, okay? And what Wepman and his colleagues were trying to get across is that this is not just duality, it's not input-output, but that there has to be this thing in the middle where symbolic formulation occurs, where something extra happens. And so there had to be, in his mind, at least 3 parts to how this language system worked. So if we took one of these single modalities, okay, in the transmission, in the input mode, and we took it out, we might end up with something like an agnosia, okay? An agnosia is the inability to recognize in one modality what you can recognize in a different modality. So an example of that is, if I see a picture of a doorbell, I say, that's a doorbell. But if I hear the doorbell ring and I couldn't recognize that it was a doorbell, that would be a sign of an auditory agnosia. Okay? Because I can recognize the doorbell and label it in one modality, but can't do it in another. It is highly modality bound. Okay? And there are many different kinds of agnosias. Okay. Next, in the output transmission, if I were to hear a word, attach a meaning to it, and decide to respond to that word, but if the motor system of transmission for verbal speech were broken, then I wouldn't be able to say that word. But I would be able to write that word because, again, the transmission is modality bound. I'm sorry, my computer is very sensitive. So the transmission going out is modality bound. This is an example of apraxia, right? So we have the word coming in, the person understands the word, they know the word they want to formulate, but they go to formulate it and they can't use these motor systems, motor tracks to create the word that they want to say. But they have integrated the language and formed the language. So these kinds of problems would be things like dysarthria, apraxia. This could be difficulty with writing, could be caused by hemiparesis. So these tend to be motor output issues. And in the inputs, it tends to be different kinds of recognition problems that occur in the input part. And we talked about that just a moment ago. So we have recognition, which is modality bound, and it's coming in. We have motor systems transmitting information out. And then we have this thing in the middle that's modality linked. It's in this symbolic integrator where aphasia then resides. It's in those neurological structures in the left hemisphere, primarily in the frontal and temporal lobes, in that zone of language, where damage to those areas results in this modality linked idea of aphasia. So if this middle part is the part that's damaged in the model, we're going to have a person who has a very difficult time using symbols in any mode because all the modes are linked together. So language is language, whether that language is spoken or whether that language is written. What is really the key is that the language itself is not specific to speech or writing or reading or auditory comprehension. It's all together in one central area where this symbolic formulation occurs. We're going to use this model to help us as we move towards what aphasia is and how we can differentially diagnose it. You'll note that in chapter 2 of the textbook, Brookshire and McNeil did a very nice job of talking about how or the role of the speech-language pathologist in coming up with a differential diagnosis, which might occur because of the information from the chart and the information that you gather from an interview with the patient, combined together with diagnostic results. It could come from a variety of sources. But that is going to be one of the things that we are going to want to do because it is going to help us link to treatment. And that's what I'm always going to try to bring you towards, is the idea that we can link the ideas from diagnosis to form a good treatment plan that helps people to change in their everyday function, because that's really where we want to be focused. Okay, that's all I have for Wepman. and I hope that you found it useful. Please go back to your article now and reread it again and see if it makes a little bit more sense to you.